Hello everyone, this is SN Ali in front of you. Today we are with another important topic of our CSWIP 3.2.2 course, that is about heat treatment, and it is a section 7 in your uh, theoretical book of by TWI official book. And I will discuss the main course contents of this chapter, which are introduction, normalizing, quenching, tempering, annealing, solution annealing, post-weld heat treatment and its thermal cycle. Um, Maybe I would not be able to discuss all of these topics in a single video, so I will make it in parts. So let's get started. Today, our first thing will be our introduction about the heat treatment. What actually is the heat treatment is? uh, whenever somebody got a fracture of his bone, what he do, or some muscle pulls on his body, so he do some bandage for the reveal of pain. Similarly, in materials, when we play with the materials, then we need to change the microstructures of them to improve their mechanical properties, to reveal their stresses, to improve their machinability, to improve their toughness. Okay, so all of these things we do by heat treatment. So this is a brief introduction of a heat treatment, and next we will discuss the different types of heat treatments. First of all, I need to share you a graph of heat treatment cycle in which we heat something, a material, and we soak them up to a certain temperature, for example 350 or 400 degrees centigrade. We heat them, the material is heated here, and then we keep it for a certain period of time, for example 1 hour. It depends upon the thickness of the material, and then we cool it to the normal temperature, that is at 25 degrees centigrade room temperature. Okay, so this cooling has this cooling has an impact on the strength. For example, if after this stage we cool it abruptly, then the microstructure will be different. If we give some time and it cool down, then the structure will be different, and if we cool further delay, then the structure will be further different. So that's why we call it normalizing, quenching and annealing. These are the three things which I will discuss in further slides. For example, normalizing. What we'll actually do in normalizing, we heat the material up to a certain limit. We roll them, or whatever we want to do, whatever shape we want to give to the material, and then after the material is held and processed in the same temperature range, in that temperature range, when the material becomes soft enough to malleable means that it can be it's a flexible, it is soft, it can be converted into any shape, and then we cool them at in normal air. That is called normalizing. The structure in normalizing is simple structure. Okay, grain structure is normal. Okay, and the strength is also good in this temperature, in this atmosphere range. Okay, the second thing is quenching. What the actual quenching is, in which we heat the material up to a certain temperature, we hold them, we process them, and we certainly quench them in water or some liquid to room temperature, 25 degrees centigrade. This is a very sharp cooling, so that's why it is called quenching. And the structure is formed BCT structure, body centered tetragon structure is there, like this. This structure is very complicated and has very high hardness. Hardness is very high in this case. It is so hard that it can be broken easily. So that's why we need to temper it to reduce its hardness to up to a certain limit to give us a benefit. And that reduction of hardness can be gained by a process which is called basically tempering. Okay, what we do in tempering, actually we need to discuss a iron carbon diagram in front of you. Let me draw a iron carbon diagram. This is the iron carbon diagram in front of you. um, these are different temperature ranges are there, degrees centigrade, and there are different carbon percentage. The maximum percentage of carbon is 6.67% in iron, which is caused in total steel, and the other is iron. Up to 2% that is a steel. This is called a steel, and above 2% it is called cast iron. In steel, we mostly deal with the steel in oil and gas industries and many other industries. So there are different phases of carbon. Alpha carbon is there, austenite is there, okay, and it is a perlite. These are different structures. So what we do in tempering, actually, in tempering, we first of all quench the material. We heat the material up to there, and we suddenly cool it up to room temperature. So when the material comes at room temperature, it does not relieve alpha phase or gamma phase. It suddenly converts into BCT structure, body centered tetragon structure, which is a very hard structure. So in tempering, what we do, we again heat the material after quenching. We again heat the material. This is the lower critical line. It is a lower critical line, which is also called A1 line. That is about 723 degrees centigrade. We again heat the material below this line, and then we cool it. So what happens is the hardness of the material reduces, which is called basically tempering. And by reducing that hardness, we can use that Martin static steel in our use, because the hardness after Martin static structure is so much high that we cannot use it, because if you will use it, that it will be a brittle material. So brittle material is easy to fracture. So that's why tempering is preferred to reduce its hardness and improve its toughness. What the toughness is, for example, there is a piece in front of you, and we pull it in a tensile test. So when we pull it, then the stress and strain is stress is increasing and strain is also increasing. Up to a certain limit, the stress and strain are directly proportional to each other. After a certain limit, it material transforms into a plastic form, and after that the material gains some higher strength, which is called UTS, ultimate tensile strength. And after that it fractures, and you can see a cup and cone type structure in ductile cases. So before fracture the material has absorbed this much of stress in it. So this is called toughness of the material, the ability of a material to absorb energy before fracture. It is called toughness. So that was the concept of toughness. So by tempering we reduce the hardness and we increase the toughness of the material so that it should bear enough stress before fracture. So in next video I will discuss the further steps: annealing, solution annealing, and PWHT with you. Thank you, stay tuned.